It should be clear from analysis of the output from the bicycle data that there was a problem with some outliers. I'd like to show you how you can actually tweak a plot so that we can account for these outliers, but also to explain the relationship between heart rate and work rate more effectively. In order to do this, I'm going to insert a graph. I'll go to Insert. I'll just choose my data first. Scatter. And there is my graph of heart rate over work rate. So I should just choose an appropriate design and I'll label this up. So this is effective work rate on heart rate. Label up the x-axis, work rate in watts, and the y-axis label is heart rate. In beats per minute. Okay, so you can see from this graph that we have an outlier here. This doesn't fit in with the overall trend. And we also have these 2 points up here which appear to be when the heart rate is actually flattening out. So I'll tweak this axis slightly first. So click on the axis using the left mouse button, right mouse click, Format Axis. I'm going to set the fixed rate to 70 beats per minute for the minimum, and then OK. OK, so that shows the data better on the graph. I want to get rid of this point from the regression line, but also show it on the graph, and also want to get rid of these 2 points. So the first thing I'll do is I will add a trend line to this graph. So I click on the data points, right mouse click, add trend line. I want a linear trend line because that's what I'm looking for. And I'm going to click on, down at the bottom, display equation on chart, display R squared value on chart, and then close. So there's my trend line. I'll just move it out of the way so we can see it. So you can see that we have a reasonably good fit to the data. The R squared value was 0.9796. So almost 98% of the variability in the data could be explained by the fitted regression line. But I think we can improve on this. And the way that we improve on this is by getting rid of the non-fitting points. And the way to do this is I'm going to insert a couple of columns in the data here. So insert. I'm going to label up a column aberrant points. I'll just resize my graph. So points which are identified as being out of fit, so the one at 100 watts, 108 beats per minute, I can actually move out of the column for the heart rate. You can see at the moment my R squared value is 0.9796. So I'm going to get rid of this point here at 100 watts. And to get rid of it, I'm just going to slide it over into this second column. So look what happens to the graph. The point has now vanished. Look what's happened to R squared. R squared has actually gone up. Our fitted regression line is now a better fit to the data. I've also got these 2 points up here. So I'm going to do the same thing. I'll just move the graph out of the way. It's these 2 points here. Go slide them over. And let's see what's happened there. So now we've got an R squared value 0.9977. the fit of the line is dramatically improved by removing these non-fitting points. Now I still want to show these points on the graph, and the way I'm going to do that is by clicking on the graph, and when I do this you'll see that we get this blue box around the data. I'm just going to left mouse click over this blue box and drag it over, and as I do that you will see that those points that I've moved over to the next column have actually now been included on the graph, but they're not part of the fitted regression line. So that's an excellent way of improving the explanation of the data. One final way, I've assumed that this is a linear relationship. So apart from these 2 points here, it looks like we do have an excellent linear relationship. Up here the heart is probably beating so fast that it can't actually keep up, continuously beating faster and faster. But I'd like to see, can we actually fit a second order fit to this data, which defines a nice smooth curve. So I'm going to move these 2 points back in. I'm not going to include this point, which was probably down to the heart monitor slipping or something like that. Click on the data, right mouse click, add trend line. I'm going to add a second order polynomial that defines a nice smooth curve. And again I'm going to include display equation on chart, display R squared value on chart, and this time I'm actually going to shove the line backwards to the y-axis, so the starting work rate was 50 watts. And close that, and let's have a look at this. So there is the second order polynomial fitted. So what this is saying is that the resting heart rate was actually 64 beats per minute, and that progressively increased at almost 0.6 beats per minute, but with increasing work rate the amount that is actually increased progressively declined. But you can see that this is also an excellent fit to the data, and it's also a very good explanation of what might happen with reasonably fit sports science and health students, most of which are athletes taking part in various sports.